Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about inverse Z transform. Inverse Z transform is a powerful tool in discrete time signal processing. This presentation will cover the definition, properties, computation steps and practical examples. Definition. The inverse Z transform converts a Z transform function, which is a complex frequency domain, back to the original sequence in the time domain. That means inverse Z transform convert the frequency domain into the time domain. Its mathematical definition, the inverse Z transform is defined as x of n is equal to Z inverse of x of z, where x of z is the Z transform of x of n. Properties. Key properties include linearity, time shifting and scaling, enabling manipulation of sequences and their corresponding Z transform. First, linear property. Z inverse of a into x1 of z plus b into x2 of z is equal to a into x1 of n plus b into x2 of n. Time shifting property. Z inverse of z power minus k into x of z is equal to x of n minus k. Scaling in z domain. Z inverse of z power m into x of z is equal to x of n plus m. Now, steps to compute inverse Z transform. Here we are using partial fraction expansion. Decompose the Z transform function into simpler terms. In second step, inverse Z transform table. Using standard table to identify the inverse transform of each term. Third step, combine terms. Sum the individual inverse transform to obtain the final sequence. A simple function. In case Z transform of x of z is here they have given x of z is equal to 1 by 1 minus a z, which is a simple function. If we want to convert this as a sequence, that means original function, here we are using inverse Z transform. Here the x of n value is equal to a power n into u of n here. Coming to the complex function, they have given x of z is equal to 1 plus a z by 1 minus b into z. Now we are going to convert this x of z into the original function in terms of xn. So by using inverse Z transform, x of n value is equal to a power n plus b power n into u of n. Coming to the application part, signal reconstruction. In signal reconstruction, inverse Z transform recover time domain signals from their Z domain representation. In system analysis, inverse Z transform analyze the behavior of discrete time system. In digital filter design, inverse Z transform transition between time and frequency domain. In control system, inverse Z transform used to model and analyze the discrete time control systems. Conclusion. The inverse Z transform is a powerful tool for analyzing and manipulating discrete time signals with application in diverse fields. This presentation provide a comprehensive introduction to the concept, computation step and practical examples. Remember, understanding the Z transform and its inverse is crucial for talking complex problem in digital signal processing. Thank you.